Hey there. In this video, we're going to be making a diagram for a very simple actuator controller circuit. So the first time you're going to make a diagram, you can hit this Create New Diagram button. You'll see that button if you're already having a project open. And let's call this guy a demo drawing. So in the last tutorial, we went through how to make a bunch of library parts. I've added a couple parts since then. But yeah, when you have a diagram open, the first thing you're going to see here is this properties pane, which gives you some high-level things. You can change your page size here on the right, but other than that, you're ready to start dragging and dropping components from your library into your canvas. So what we're going to do is drag in a battery. If you grab the title row, you can switch the orientation, or sorry, the side that the port's on. Let's bring over our single board computer. We're going to have a bulkhead connector. So I'm going to bring in a female and male DB9, and I'm going to mate those guys. And then we are going to have two actuator controllers and two motors. And let's flip the direction there. And then I can do like all my standard copy and paste actions too. Cool. So now we're just going to go ahead and start connecting things. We have a couple ways that we can add cables. We can either drag in a component directly from the library, or what I can do is draw a wire in here and then click on this guy and assign a part name myself. Now if I select these, I can also like show and hide different attributes depending on what I want to see in my diagram. So here, next what I want to do is connect serial. So let's bring this guy here, and since I have 8 pins here, I want to have my ground reference on the back shell. So what I'm going to do here is if I click the port, over on the right properties pane, I'll actually see these ports and pins table. So there's two things that I want to do. First, what I want to do is break this out into two, we're calling it subports, which means it's part of the same physical port, but it's split off organizationally into two things that look like ports. Now you can always like rename what this is going to be, but I'm just going to keep it as P2.1 and P2.2 just to make it clear that it's part of the same physical connector. The next thing I'm going to do is actually add a little back shell termination here. And what that's going to do is it will let me actually terminate a wire to the back shell connector of P2. And that's going to give me a ground reference point for my shield wires. So let's go ahead and start connecting things. I am going to drag this guy over here, and let's copy and paste this guy, move shield out of the way. Let's terminate this, and then we'll move shield here, and then let's actually put shield here first, and then I'll terminate these guys like this. And as you can see, the function names actually cascade to the connector from the device itself. Our philosophy with mated connectors is at any point you should be able to disconnect those connectors and see, hey, what's the function of the pin at that connector that I'm looking at? So I have the back shell pin here, but you can also click this guy and rearrange it as necessary just to minimize the number of like wire overlaps that we're seeing here. And then when you do that, you'll get this pins reordered warning that you can always like show and hide in the main properties pane. Let's see, so okay, I have power here, I have this. You can always like do custom routes if you want. If you need to like dodge different components, and then hit that auto route edge button just to go back to the old defaults here. Next, let's bring these guys back, and we're gonna do this here. I'm gonna add a little back shell termination here too. Perfect. And anytime you have something like this, you can actually see what is on one side and what is on the other side. So here we have the very, very classic TX to TX, RX to RX problem. So what I'm going to do is actually disconnect these guys and make sure that I have the right RX plus going to TX plus and TX plus going to RX plus. So let's flip these guys, which is, it's a cool feature to be able to make sure you're catching any things that are backwards here. So now I know, okay, my mating connector is set up right and my wiring's set up right as well. And lastly, what I'm gonna do is have my actuator controllers going out to the motors itself. So I have 2 pins on the output going into 4 pins on the input. So what I'm gonna do here is I'm just gonna have a splice for each one of these guys. I'll copy and paste it. So I can have a wire going to each one of these outputs, and we're gonna connect these guys just like that. And then I'll copy paste this guy and match it on the same here. It looks like I had. There we go. Sweet. Alrighty. So now I have like my diagram that's all drawn out here. I talked about subports. Let's say that I want to add a pin table for this thing here as well. So anytime I click on a device or a connector, what I'll see is this Show Pins Table button. And this is going to be the very, very typical pin table that you're used to seeing, that you can click on different items within a device, or if I want to show a connector, it'll show me either side of it. It'll show me the color of the wire, a reference designator, if I've added that, wire part numbers, lengths, all that good stuff. If I click on a wire, of course, I can add cable reference designators as well. So let's call this guy RS422, let's call it M1. And let's call this guy RS422M2. And because I've added these reference designators, you'll see those columns update accordingly as well. Let's see. Last thing I want to talk about on making a diagram is you have a bunch of annotations that you can add to. So things like text boxes, where you can double click on it and change different inputs there. You have your standard arrows, circles, rectangles, but you can also add things like annotations here. So I feel like the one like kind of ambiguous thing that I had here was this backshell shield termination. So I'm going to add a build note here and say like terminate this to a ring lug and it to the backshell. So that's one way of doing it. But you know, now that I think about it, if I have terminated something to a ring lug, I probably should actually just bring in a ring terminal. So that's actually what I'll do. I'll bring in that ring terminal and I'll connect that to a backshell. I'll have these guys and I'll move this annotation here. Let's see. So another thing that I can do is actually trace nets through different components. So because I have some wires coming in on one side of a connector and through the other side of the connector, I'll often actually want to see that electrical route through the connector itself. So if I click on a wire, I can also show a net here, which will actually select and highlight the entire route that the net takes. I can also, on the note of annotations, be able to click this button or drag it in, and I can actually like add in a data sheet. So this is like a very fake data sheet that I had for a motor controller, just a random PDF that I got online. But it's something that I can actually drag in and put in my diagram. So anyone who might have opened this diagram up can actually see the data sheet as well. So lastly, what I'm going to do is talk about exporting. So now that I have this on my table, you know, maybe I've set some fun colors that make it clear. I also want to be able to export this. So like I mentioned before, you can set your page size and all that stuff to make it, you know, the most friendly for actually printing this out and sharing it within your organization. You can also do things like group your different components as well. So I'm just going to highlight this guy. Let's select this group. We're just going to call this group, I don't know, left brake, because I'm assuming that this is like a brake solenoid circuit. And I'll call this guy the right brake. Fantastic.